Hi everyone, today, we will continue to explore in depth how to use microprocessors to implement DSP functions. In the previous video, we learned about the consist DSP library. Today, we're going to talk about the story of Fourier transform FFT, from the physical meaning to the algorithmic principles, to its ubiquitous presence in practical implementations. The French mathematician Joseph Fourier proposed it in the 19th century. Any periodic function can be represented as a combination of sine functions of different frequencies. This means that no matter how complex a signal is, in theory, it can be decomposed into a sum of sine waves. With the theoretical foundation in place, it is naturally not difficult from now on. In digital signal processing DSP, we need to process thousands of sample points. At this point, the discrete Fourier transform DFT is used. However, the time complexity of the DFT is ON. Therefore, we generally use the fast Fourier transform FFT. It can reduce the computational complexity to ON log n. In the consist DSP library, it provides functions for complex FFT, real FFT RFT, and discrete cosine transform DCT. Compared to RFT and CFT, it utilizes the symmetry of complex numbers. It can significantly reduce the computational load. It can be seen that the RFT provides functions for computing various data types, including float and double, as well as Q15 and Q31, which are suitable for fixed point operations. Next, let's look at a practical example. The sampled signal is acquired through the ADC at 5 ms/ps. Then, the transformation is performed using RFT. This is the FFT result of a 10 kHz square wave. It is very close to the theoretical result.